Hello guys, in today's video I'm going to show you how to prove the quadratic formula or the so-called almighty formula. Yes, let's begin quickly. Remember, the general quadratic equation is written as ax squared plus bx plus c is equal to 0. This is the general quadratic formula. So we are going to prove the almighty formula, or what we call the formula method, from this same equation that you see right here. So there are a few steps you need to follow to be able to do this. Actually, the method I'm going to show you of proving this quadratic formula is following the completing the square method. So I'm going to simply be stating out the different steps that we will need to follow to be able to solve or prove the quadratic formula or the almighty formula as you know it. So follow me stage by stage to make sure that you are able to follow sequentially all the steps that you need to follow to be able to solve or prove the quadratic method. Okay, so let's dig in. The very first stage that you need to implement at this level is equate the whole formula to C. That is the constant value as you see here. So what I mean by equating it to C is something like this. I'm going to remove the C from the left hand side of this equation and take it to the right hand side, which is obviously going to make it a negative C. So if I do just that, what I'm going to find is something like this. Ax squared plus bx is equal to minus c. Having done this, the next stage you will need to follow is to divide each term on both sides of this equation by the coefficient of x squared. And from here, the coefficient of x squared is a. So simply say divide each term on both sides of this equation by a. So if I do that, I'm going to divide this by a, I'm going to divide by bx by a, I'm dividing minus c by a also. When we simplify this, a cancels out a. So we're having a squared plus bx over a. You write this like this is equal to minus c upon a. Okay, after this level, the next thing is look at the coefficient of x, which is b over a. What we are going to do right now is we are going to add the half of the coefficient of x to both sides of this equation. I repeat, I am going to add the half of the coefficient of x to both sides of this equation. And to do that, let me show you exactly what I mean. Adding half of the coefficient of x, which is b upon a. So I'm going to add half of b upon a to both sides of this equation, like this. It's going to be x squared plus b upon a with a coefficient of x. Now I'm going to add half of this. So to add half of this, I simply open a bracket and write b upon a times 1 over 2. This is half of it. The same thing exactly in this bracket, I'm going to add it also to the right hand side of this equation this way. Since I already have minus c upon a on this side, I'm going to add exactly the same terms and values you see in this bracket right here, which is b over a times half. Okay, having done this, the next level I'm going to go to is take the square of these brackets on both sides. So that's a very simple step. Usually some persons combine these steps together, but I just wanted to separate them one from the other so that you don't get confused. So the simple thing to do is give it a square here and give it a square. Now, the principle behind proving this formula is that once you get to this stage, we are not going to work with this anymore. So we automatically are going to combine x squared with b over a times half, close the bracket, squared on the left hand side. So the next thing I'm generating together will be x squared plus open bracket b over a times half, close the bracket, squared, which is equal to minus c over a plus, now let's simplify the bracket. If I multiply b times 1, I'm going to get b upon a times 2. You can write a2 or simply you can write 2a to avoid thinking that a2 is the same thing as a squared. Now don't forget your square, which is exactly this. All right, since we've simplified the our right hand side in this equation, what I'm going to do slowly is also to simplify the left hand side a bit. To simplify the left-hand side of this equation means that I'm going to change the b over a times 1 over 2 close the bracket squared in the same way as I have done on my right-hand side right here. So this is exactly what I'm going to do on the left-hand side. Like this, I'm going to write x squared plus my b times 1 is going to give me b over a times 2 is going to give me 2a. So this is also squared right here. All right, is equal to minus c over a. I can open this bracket, right? I can easily say is plus b squared is the same thing as b squared, and 2 squared is 4, while a squared remains a squared. Okay, I believe you're following me. Now, the principle behind proving this formula is that when you get to this stage, x squared and b upon 2a squared are seen as together. Because both of them have their exponents as 2, we are going to combine them this way. It's going to become x plus b upon 2a, close the bracket, squared. Some time ago, my students have asked me if this is always true. Well, mathematically, this is not always true, but this is the brain behind the proof of the quadratic formula. So let's go further. Okay, this is equal to, we can simplify this stage. As you can see, the two terms we have here are just fractions. So we can simply simplify them by working it out. The LCM for a and the 4a, which is the denominators together, we have it as 4a squared, right? So let's work it out. When you divide 4a squared by a, you're going to get a. So a times negative c is going to give you negative 4ac. Okay, now plus 4a squared divided itself gives you 1. So 1 times b squared leaves you with a b squared. Okay, having reached this level, let's see how far we can progress. I'm going to simplify the right hand side first before I proceed. So what I'm going to do next is, since I already have this, I leave my left hand side the way it is because I want to simplify the right hand side first. So x plus b over 2a close the bracket squared is equal to, now let me just make something easy. Since I have b squared positive, let me just keep it in front. Why I have minus 4ac all over 4a squared. Okay, we are very close to our destination at the moment. Now, for me to simplify further, I have to remove the square on the left hand side. And remember, the only way to take away the square on the left hand side is to take the square root of both sides like this, so that the square root on the left hand side kills out the square on the left hand side. So that at this stage we are left with s plus b upon 2a. We have this here is equal to, our square root can be a positive or a negative square root value. Okay, square root of b squared minus 4ac all divided by 4a squared. Now remember in your sword that when you have a square root covering both the numerator and the denominator, you can simplify the right hand side by writing plus or minus the square root of b squared minus 4ac divided by the square root of 4a squared. This is very mathematically correct. So I'm just bringing down the left hand side the same way it has been before. So I'm having it as x plus b all over 2a. It remains exactly that way. The reason I've done the right hand side is what I want to show you now. So watch. I did it simply because I want to simplify my right hand side and I do not want you to get confused. Therefore, let's simplify before we proceed with carrying over terms from the left hand side. Now it's going to be x plus b all over 2a is equal to plus or minus. My numerator cannot be simplified, so I leave it the same way it is as b squared minus 4ac. Oh, sorry, it was 4ac before. I think I left it up there. Okay, b squared minus 4ac divide by, if I take the square root of 4, it gives me 2, and the square root of a squared leaves me with an a. All right, so only our numerator here has the square root. Therefore, we can proceed with the simplification this way. I'm going to make x the subject of formula. So x is going to stay alone on the left-hand side, which you can see here, while my plus b all over 2a crosses to the right-hand side, and that turns into a negative b over 2a, as you see it here, plus or minus the square root of b squared minus 4ac divided by 2a. Now watch the denominators. Can you see that we have common denominators of 2a right now on our right hand side? In that case, we can simply combine them by saying that x is equal to minus b plus or minus root b squared minus 4ac. Everything is all over 2a. Now this you see here, which we just created, is the same thing as your formula method, or what you may call the almighty formula. So if you can follow these steps I just showed to you, you will simply land yourself at the correct proof of the almighty formula you know about in mathematics. Okay, I just decided to drop this here and I believe it's going to help somebody today. Please remember to subscribe to this channel, visit it regularly for more updates.